What is a differential equation? Now, if you guessed that it's an equation containing differentials, you're right. So it's an equation that may involve either differentials or derivatives. So let's write down an example. Dy over dx is equal to 0. So it's an equation that involves derivative of y with respect to x. Now we can write one more example. Say d square y over dx square, and the derivative could be second order derivative plus y is equal to 0. So that's another differential equation. And we can have, maybe let's say, dy over dx quantity cubed plus 3y is equal to 0. Or you could have something like y dy over dx is equal to 7x minus 3. So these are all examples where you can see these are all equations, and you have a first order derivative here, a second derivative here. Here you have first derivative, but it's cubed. And here you are multiplying the dependent variable with the derivative. And actually, let's go ahead and write one more example. X plus 2 dy over dx is equal to 3. So these are all examples of differential equations. Now in this class, you will study how to solve these differential equations. Now when you solved linear or quadratic or any polynomial equations, your solutions involved either real or complex numbers. But when you solve differential equations, you obtain functions. And you learn how to get those functions. Now, we have some certain terms in differential equations. One is the degree. So, degree of a differential equation is the highest power of any derivative you see. So, here it's 1, and here also it's 1, even though this is a second order derivative, the exponent of that derivative is just 1. But this is degree 3. Now, whenever you have a degree 1 differential equation, that's called linear. And linear differential equations are something that may have a higher order derivative, but you don't see an exponent. So this is a linear differential equation. That is a linear differential equation because you have only first, the derivative appears only in the first power. But this is not, because of that cube. Now, this one is also not a linear differential equation because the dependent variable is multiplied with dy over dx. So that makes it non-linear. Now, why do we care to have that classification of linear and non-linear differential equations? Is because when your differential equation is linear, you can use the tools from linear algebra. And if you have not known any linear algebra, or if you are going to have linear algebra in the future, then learning about linear differential equations will provide a rich class of examples of the things that you learn in a linear algebra class. So linear, non-linear is one classification of differential equations. One other classification is if your derivatives are all ordinary derivatives, meaning your dependent variable is a function of just one variable, like in all these examples. Y was the dependent variable, it was a function of just x. So that's why we could use these dy over dx or d square y over dx square. But if your dependent variable is a function of two or more variables, then you can talk about partial derivatives. And if you have partial derivatives in your differential equation, that would be called a partial differential equation. In subsequent videos, we will learn about solution methods for ordinary differential equations, and we will spend a whole lot of time on solving linear differential equations.